How's it going, everybody? Mr. Dickin here. In this video, we are going to be solving quadratic equations by factoring or using tables or graphing. Factoring will be done by hand, and when we do tables/graphing, we will be using technology. And if you know anything about me, you know that I am president of the Desmos fan club. All hail Lord Desmos. So that's what I'll be using when it comes time to do those. So first, let's get into something called the zero product property, which is absolutely pivotal when we are solving by factoring. Now, when we're finding zeros of a function, zeros are basically x-intercepts. Zeros of a function are whenever you have a function value or a y value of 0. So if the y value is 0, that means you're a point on the x-axis. We've discussed before the only things we really care about with regard to parabolas are the x-intercepts, also known as zeros or sometimes roots. We like the vertex, and then also the y-intercept. So for this one, we way down here somewhere. So the zero product property states, and this isn't just for quadratics, this is in general, if you have two quantities being multiplied together, so a times b equals 0. If you have two quantities being multiplied together and the result is 0, then one of those two things has to be 0. Maybe both are, but one of those two things has to be 0. And if you think about it, if I had an equation like 4x equals 0, 4 times some mystery number equals 0, well then x would have to be 0, right? That's the only way to result in an overall product of 0. So anytime you multiply something by 0, you get 0 as a result. Now, we'll typically see this as two parenthesis chunks. So, and I'm making these numbers up. Let's say x minus 1 or x minus 2. So we're going to see the product of two factors is equal to 0. So then the product, or the zero product property states that one of these two factors or quantities has to equal 0. So either x minus 1 is equal to 0, or x minus 2 is equal to 0, or maybe both of them are equal to 0. But if the product of these two factor terms, if the product is 0, then one of these two chunks has to be 0. So if that's the case, I could argue that either x has to be 1 or x has to be 2. So if I were to plug in 1 or 2 into this equation, like if I plugged in 1, I'd have 0 times negative 1. Well, 0 times anything is 0. If I plugged in 2, I'd have 1 times 0. Well, anything times 0 is 0. So either one of those numbers would result in a product of 0. So that is going to come into play quite a bit when we're factoring. All right, let's get to it. So we want to solve the following by factoring. If you need to pause the video here to write these down, by all means, please do so. When we are factoring, it's going to be very important that we set things equal to 0. So if it's set equal to f of x, you can just replace f of x with a 0. That's totally fine. In situations like 3 and 4, we're going to have to do some rearranging. Now, when we factor, our goal is to get these expressions or equations broken down into their parentheses chunks or their components. And we always want to start off factoring by looking for the GCF first. So greatest common factor comes first. All right, let's take a look at number 1. Number 1 is x squared minus 5x plus 6. And like I said, I'm going to set that equal to 0. There is no GCF between x squared, negative 5x, and 6, so I can go straight into my parenthesis chunks. I'm looking for numbers that would multiply to be a positive 6, but add up to be a negative 5. So numbers that would multiply to be a positive 6, but add up to be a negative 5. Those numbers would be a negative 2 and a negative 3. Now, according to the zero product property here, I've got a product of two factors that equals 0. So one of these two, or maybe both, one of these two has to be 0 if the overall product is 0. So that means x minus 2 is equal to 0, meaning x would equal 2. Or I could say x minus 3 is 0, which means x would equal 3. Either one of these two numbers would be solutions to this equation right here. If I plugged in 2, I'd get 4 minus 10 plus 6. Yeah, that's 0. If I plugged in 3, I'd get 9 minus 15 plus 6, also going to be 0. So by factoring it down and using the zero product property, we can get our two solutions. Also, general rule of thumb, if you ever have an x squared, means a quadratic, you can expect up to 2 values for x. You might have only one, you might have none at all if it's not factorable, but you will never have more than 2. All right, number 2, 6x squared plus 4x equals 0. This one's already set equal to 0 for us, so I need to look for GCF first. I've got 6x squared plus 4x. Well, they both are even, so I can take out a 2. And they both have at least one x to give up. So I can factor out a 2x, and I'd be left with 3x plus 2 equals 0. So I've factored that out. I've divided the GCF, or the greatest common factor, out of the 6x squared and the 4x. Now I can use the zero product property. Either 2x is equal to 0, in which case x is 0, or maybe 3x plus 2 is equal to 0, in which case I'd move 2 to the other side, divide out the 3, I'd get x equals negative 2/3. Again, 2 answers for having an x squared. If you ever have a linear factor that looks like this and you're trying to solve it quickly, a little shortcut, take the opposite of the second number divided by the first coefficient. So negative 2 divided by 3, bam, negative 2/3. Little shortcut for you. All right, number 3. X squared minus 7x equals negative 12. We kind of foreshadowed this one. It's not set equal to 0, and that should bother us. So we're going to go ahead and make it equal to 0 simply by moving the 12 to the other side. Now that it's equal to 0, I'll factor it out. There is no GCF, so I just need to look for numbers that would multiply to be 12 but add up to 7. So if I think of factors of 12, I've got 1 and 12, 2 and 6, or 3 and 4. I'm thinking 3 and 4 is going to be the winning combo. Whoopsies. There we go. 3 and 4 would be the winning combo. They're both going to have to be negative, though, if my sum is negative 7. The product of two negative numbers would still be a positive, though. So now that I have this factored out, set equal to 0, the zero product property states that one of these two factors must be equal to 0 if the overall product is 0. So I can set each factor equal to 0 and solve that one, sometimes two-step equation with ease. All right, number 4. Number 4, I'm going to solve it properly first, and then I'm going to show you guys a cardinal sin that some people do. So let's solve it properly first. We're going to set it equal to 0, so I'm going to bring the 8x over to the other side, set equal to 0. Yay! Then we'll factor out our GCF, which is 2x. That leaves me with an x minus 4. And now I've got two different factors. Zero product property says one of those two factors has to be equal to 0. So x might be 0, or x could be 4. Either one of those would give me a 0 as an answer. Now, the cardinal sin some people make, and please, for the love of all things good, do not do this. So I'm going to put this disclaimer here, just in case this is like chosen as the thumbnail for the video. I don't want people out there thinking I'm preaching falsehoods. Some people will take this 2x squared equals 8x, and can you believe the nerve? They will divide both sides by a 2x. And then they'll think, all right, cool, the 2's cancel, and one of the x's cancel, so I have a plain old x on the left. Over here on the right side, see, 8 divided by 2, that's just a 4. And then the x's cancel, so boom, x equals 4. So this is what some folks, hooligans you may say, will try to do. The issue with that is right here. We are dividing by x. Well, what if, per se, that x value is 0? We just divided out a 0. You can never divide by 0. If you divide by 0, the whole universe will implode in on itself, and everything you've ever known or loved will then cease to exist. So that is a cardinal sin people tend to make, and when you do that, you will ignore one of your two solutions. So please, don't do that. Don't be that person. All right, moving on. For these problems, I've got the answers written out. So what I'm going to suggest is that you write these out, pause the video, write out these problems, attempt them. Once you have your answers, unpause the video, and then the answers will be on here. Okay, so pause the video, try them, and then unpause once you have the answers. So for the first one, after you set it equal to 0 and factor it out, you should get the answers of -5, 0 and 1, 0. So when we are writing these out, you get x equals -5 and x, and x equals 1. But we'd want to write those as coordinates. Number 2, you're going to have to move the x and the 4 to the other side and then factor it out. This one's a little bit trickier because we have this 5 out front. This 5 ruins everything. So to get a 5x squared, we break that apart into a 5x and a 1x. And then we have to figure out the numbers that would go in the second spots here. And once you have a coefficient, the order becomes important, right? A 1 here versus -4 here is extremely different than a -4 and a +1. So we have to kind of be careful with our factoring there. Number 3, just set this equal to 0 and factor it out. There are the factor pairs there for you. Preferably, when we were writing our answers, we prefer fractions, but decimals are still numbers too. Just be careful if you ever have to round. And then this last one, we get -3.35 gross and 1.35 gross. So for that last one, if we were to try factoring it, I'd have to start off with a 2x and a 1x. The second term has to be product or factors of 9, so I'm going to go ahead and just try 3's, see if that works. If I do that, I'd get a 6x and then a 3x. There's no way I can combine a 6 and a 3 to get a 4 in the middle. So that would be out. And it would be pointless for me to switch those around because it's just 3 and 3. The only other thing I could do is maybe a 1 and a 9. So if I put a 9 here and a 1 here, let's see, that'll give me a 2x and a 9x. There's no way to get a 4x out of that. So that's out. Maybe I could switch it. Put a 9 here and a 1 here. Or, no, that's what I just had. What am I doing? 9 here and a 1 here. Well, that would give me an 18 and then a 1x in the middle. So some of you might be having good old-fashioned forehead scratching moment, which is good. So there will be scenarios in which maybe our functions do not factor out nicely. Now, if they don't factor out nicely, you have what's called an irrational answer. If it does not factor out nicely, you'd have an irrational answer. So let's see how we can maybe tackle situations like that where it does not factor out. Well, one option is using a table. And you can use some technology. You know me, I'm a big fan of Desmos. You could use your TI-83s or 84s as well. You could use your technology to figure out where exactly is the y value equal to 0. So here we have an example where I'm seeing two different spots, -2 and -1, in which my function value, my y value, is 0. Those would be the solutions to this quadratic equation. If I were to set this thing equal to 0, my answers that I would get would be -2 and -1. Of course, we'd want to write those as coordinates after we've solved it. So we can find that out from a table. Similarly, over here, we'd have two solutions. We got -3 is one of them, and we've got +1. We don't really care about this 0 because that's an x value. I only care about y's being zeros. So tables can be super fast to find our answers. That is until maybe we have a situation where zeros don't show up as cleanly or as pretty. So here I've got an example, 5x squared plus 32x plus 12. So let's say we have a table that we've created either in Desmos or on our TI calculators, either or. One of them is a clean number showing up, nice and neat. So one of these is going to be -6. The other one, though, is not showing up. Bummer. But we could maybe hypothesize where this is happening. If I look at all these y values here, these are all negative y values, negative y values, negative y values, and then it jumps up to positive. Well, if I were to think about a graph, negative y values are all below the x-axis. So if I've got a negative y value, negative y value, negative y value, then it switches to be a positive. Well, at some point it had to go through 0, right? So the 0 value is kind of like the gatekeeper between negative land and positive land, which means somewhere in here, and I don't know exactly where, but somewhere in between negative 1 and 0 for x, we would have our other x-intercept. We would have our other solution, our other 0. So here's how we can do that using technology. Again, I use Desmos. You know me, big fan of Desmos. Here we have the equation 5x squared equals negative x plus 4. First thing we're going to want to do is move everything over to one side of the equation, so that way we can essentially be setting it equal to 0, and we can look for zeros on our little table. All right, so that's the primary goal. I'm noticing right off the bat that I have a 0 right here at negative 1. And graphically speaking, yeah, it looks like, hey, that's accurate. My other x-intercept, if I look over on the graph over here, it doesn't really appear like it's going to be as pretty of a number. But if I look at the table, I can tell that it's certainly somewhere between 0 and 1, because that's when I go from positives to negatives. My y value over here is positive. Over here it's negative. To go from positive to negative or negative to positive, you have to go through 0. So then here's where I kind of start playing a little what if. All right, start playing a little what if. And that's where I say, well, what if instead of counting up by ones, maybe I count up by halves? And it's still positive, and I'm trying to figure out when does this thing shift from going positive to negative. Maybe instead of counting up by halves, what if I count up by fourths, like 0.25? Okay, still positive, still positive. Well, then I started kind of like in front of, maybe instead of not 0.5, not 0.25, what if I count up by 0.05 from there? So I went to 0.8. And you'll notice 0.8 actually gives me the other 0. So when we're using technology, we might have to customize our table values. We might have to customize the x values or change how we're counting in order to see these solutions. Typically, good things to count up by, 0.05s are great, 0.02s are great, 0.2s, 0.5s. But all of that will go by the wayside as soon as you learn how to do it with a graph, and that's what's coming up next. So here we have solving quadratic equations by graphing. So again, you know me, big fan of Desmos. I use Desmos for these. In order to solve these, I go straight to Desmos and plug these in. Now, before I do that, I have to make sure that everything is set equal to 0. So everything has to be stacked up on one side of the equal sign. Number 1 is already done for me. Number 2, I'll have to bring that 12 over to the other side. But if I look at number 1, I had my equation. I typed it straight into the Desmos. And when I do that, Desmos is great, and it tells me the solutions right there for me. Would you look at that? How neat is that? So my x-intercepts are -5 and then positive 1.5. When you type this into Desmos, you can kind of see here as well, when you click on the graph itself, these little gray dots will pop up. And if you click a gray dot, it will actually show you the coordinates there. Number 2, as we kind of previously alluded to, first thing we had to do is bring that 12 to the other side. So that's why you see this -12 over here, because then that gives me permission to think, what if I set this thing equal to 0? On this graph, I had to zoom out just a little bit, but Desmos is great. It's just a little pinch and stretch to zoom. And I'm seeing that we've got 2 x-intercepts at -5.528 and 0.362. These are both irrational values, right? They're kind of gross decimals, which tells me this would not factor out nicely. On the first equation, since these are nice clean values, right? 1.5 is really 3 halves. It's a rational number. That tells me that if I really wanted to factor this out, I could factor it out in order to get my solutions. But now that we have Desmos, we can punch these into a graph and just see where it hits the x-axis and move on with our lives. All right, that's it. You know the drill, folks. If you have any questions, please let me know. As always, good luck, have fun, be safe, roll tide.